In electronics, there are several types of buttons, such as the momentary push button, which is what these are, and the toggle switch, which is what this is. Both types have different advantages and uses, but the basic principle is the same. They both use mechanical force to make or break an electrical connection. Now, as you watch me push down on the buttons, you'll notice they pop right back up after I take my finger off. This is because they have a small spring inside them, which makes it so they only stay down for an instant. This is why they're called a momentary push button. In contrast, the toggle switch stays in its position until I manually change it. Alright, the next step is wiring. Besides a Raspberry Pi and the button, the only two things you'll need are two wires, one to connect to ground and another to connect to a GPIO pin. If you look at the button, there's two pins here. The important thing is that these two pins are not connected when the button is not being pressed. When I press the button, the circuit is complete and they are together. Now, make note of their position as I put them into the breadboard. I'm going to connect one side to ground, and I'll connect that to the Raspberry Pi. And I'm going to connect the other side to a GPIO pin, pin 15 specifically. Alright, this is how it should look. And with that complete, let's move on to coding. The purpose of this program is going to be to detect when the button is pushed. So let's just import GPIO and time, and then let's set the pin mode to BCM, and then we'll set the button to 15, like I mentioned earlier, and we'll set the pin as an input. And right here, this is going to be using the internal pull-up resistor to designate the unpressed state as high. So set button as input and use internal pull-up unpressed state as high. Then we'll go ahead and store the initial state of the button, which is when it's not pressed. And this will be useful later. So store the initial state of the button. And then we'll go ahead and just declare this little variable, which will be useful later as well. And now for the actual program. So we're going to have this continuous loop. And what I'm doing right here is storing the current state of the button. So store it. And then we want to check if the button state has changed from the initial state, the previous button state. So if button state is not equal to previous button state, we'll want to first update the previous state. And we want to do an if statement. If button state, so if the button is pressed, we'll want to do two things. Update the press counter by 1 and print button pressed and how many times. any. And then we'll want to do a quick sleep function to not use up the entire CPU. So this will repeat 100 times a second. And I think that's all we need. We'll just do the accept keyboard interrupt. And you'll always want to do the GPIO cleanup. And then just save that, and we should be good to go. All right, so I've turned the Raspberry Pi on and started the program. I'll go ahead and press the button 5 times. And if I look over here at the output shell, you can see that it recognizes each press. And if I press it a few more times, you can see that it continues to recognize each additional press. All right, so now that we have the button figured out, the next thing I'm going to do is modify this code to turn an LED off and on, just like a light switch. And this should only take 4 or 5 lines. So the first thing I'm going to do is just add the LED pin as 16. Then I'm going to go here and set up the LED pin as an output. Then I'm going to go set the initial LED state as false. And in this if statement, which is actually checking if the button is pressed, I'm going to add a statement that changes the LED state. And then we're going to actually set the LED on. And this should do it. All right, here is the circuit in action. As you can see, when I press the button, the LED stays on until I press the button again. So we've actually got this momentary push button acting like a toggle switch. So yeah, thanks guys for watching. Let me know if there's anything else you'd like to see.